So we're going to go ahead and start this process again of taking a graph, identifying the attributes of the graph, and then using those attributes to create the equation or build the equation that corresponds to that graph. So we did this before when we were only dealing with changes in amplitude and period, and now we're going to add in a vertical shift and see how that changes things. So we're not going to use a phase shift, we're just going to use a vertical shift in this particular case. So again, we're going to assume no phase shifts have taken place. So we're going to go ahead and start there. Phase shift is 0, no phase shift. Okay, so we are not moving to the left or to the right. So let's take a look at this graph, and the first thing I notice is, oh, this hill is much smaller than this valley, which means this has actually been shifted down off of a midline of the x-axis. So all of our other graphs before have been where the midline lies right on the x-axis. So a hill on top of the x-axis is the same height as a valley below the x-axis. Well, this is not the case. So we need to first find where our midline is. And you can see that if I were to go above the x-axis and try to put a midline there, well, our hills would be much smaller than those valleys. So we're going to think about going down below. Now, we want the hill height to be the same as the valley depth, okay? And so you can kind of see where this is going to be. But you can also think about this in terms of what is the average of the height. So if I take 4 plus -8, add those together, I'd have -4, and then divide that by 2, I'd get -2. And that is going to be where our midline lies. Okay, there we go. All right, and you see that now my hill, if I look above that midline, it's the same height as the valley. Okay, perfect. Well, let's go ahead and put that in. We know that our vertical shift is down 2. All right. Now this allows us to really look and determine what our amplitude is, because we're going from our midline to the crest of a hill or the bottom of a valley, and we can see that our amplitude is going to be 6 units. Perfect. Okay, so let's go ahead and put that there. And let's go ahead and adjust our parent function to have this 6 as a multiplier to the function. Beautiful. Now I want to determine, is there a reflection or not? And we look at that when there's no phase shift. We look at what's going on directly to the right of the y-axis. And notice directly to the right, we're going down first into a valley instead of up into a hill first. So that means yes, there's a reflection. Otherwise, we would start with a hill first and then a valley. So yes, there's a reflection over the x-axis. And what that means is we will put a negative on that multiplier. This signifies a reflection over the x-axis. Okay, beautiful. Now let's look at that graph and try to determine the length of the period. Now the period is going to be either from crest to crest, or valley to valley, or along the midline, including one hill and one valley. And that's the way I'm going to look at it this time. Okay, you can look at it in any of those ways. This function works very well to look at it in any of those ways. And I challenge you to see if you can see the period length in all of those fashions with this function. You notice that if I look at one hill and one valley, then the distance along that midline is going to be 4 pi units. I can see that on this side it's going to be 2 pi units. On this side it's going to be 2 pi units. And so the whole thing together will be 4 pi units. Perfect. Okay, now remember that in order to write my function, the equation of my function, I need the b value, right? It's not the period in here, it's the b value. And the period is equal to 2 pi divided by b. So I'm going to say 2 pi divided by b is equal to 4 pi, and that will allow me to solve for b, and b will end up being 1/2. All right, so now I can go ahead and put this part into my function. It's going to be the coefficient of my variable. There it is. Great. Now there's only one thing that's not in our function, the equation of our function, and that's this vertical shift. So the last thing I'm going to do is tack on that minus 2, and there I go. There's my function. This last example, this is one where I've put a vertical shift in it so that we can see what to do with that. And when there's a vertical shift, you can tell that has happened because the graph is no longer centered over the x-axis. So you need to kind of look and decide where is the midline now. And it's a good idea to go ahead and just sketch that in, because once you sketch it in, it's easier to see what all the components are. Okay, so let's go ahead and find the amplitude, which remember is the distance from the maximum to the midline. Okay, and in this case, we have 4 units here. The amplitude then is 4. Go ahead and add that in. How about the reflection? Is there a reflection? Look directly to the right of the y-axis since we know phase shifts have happened. And we can see that we initially go up to a peak from the y-axis. So there is no reflection here. How about the period? The length of the period here. Can you see it? You write down what you think it is. Okay. You should have gotten 4 units. So 1 complete cycle. And so we can use that to determine b. 2 pi over b is going to equal 4. So b will equal pi over 2. While this function does not have a phase shift, it does indeed have a vertical shift, right? The midline has been shifted up 2 units, and so that means our vertical shift is up 2. And we can add that on to our function. So our completed function will be y is equal to 4 times the sine of pi over 2t plus 2. All right, that takes care of this one.